Hi, everyone. I want to thank you for attending our webinar this morning, hosted by Axial and Talari, where we're going to be introducing Talari's WAN solution. It looks like we still have some people joining, so it's just now right at the hour. We'll wait about 30 seconds a minute, let everyone join, and then we'll get started. So if you just joined, I just want to say again, thank you for joining. We'll start in just about half a minute here as let a few of our stragglers come in. Okay, so it's a couple minutes after the hour, so hopefully everyone's had a chance to join. Those of us in the US have had a chance to get our coffee. So I want to thank everyone again for attending this webinar. It's hosted by Axial and is with the purpose of introducing Talari. And my name's Donna Johnson, but I'm not going to be talking much today. This is not my presentation. But I do want to go through just a couple of logistics. If anyone has questions, you can type them in the chat box, or you can ask them. I believe you have a question option on your control panel. And then you can also do what's called raise your hand, and we'll see, and we can actually unmute your mic, and you can ask a question during the presentation. But if you have anything you'd like to ask while we're talking, just type it in either the question or the chat box, and we'll either answer it out loud for everyone, or I'll just type in a private answer to you. So I think that's everything. If everyone's ready, and if all our presenters are hopefully ready, I want to first introduce Guy Blackman, who is the sales director at Axial Systems and your main host for today. Guy, are you there?
I am here. Hopefully everyone can hear me.
I can hear you.
Great. Thank you very much, Donna. Good afternoon, everybody, and thank you for joining the webinar this afternoon. In a couple of moments or a couple of minutes, I'm going to hand over to Alex, who's going to give you a full and hopefully very interesting rundown on the Talari solution. Before I do that, I just wanted to just tell you a little bit about Axial Systems and why we think the partnership with Talari would be a good way for anyone that's interested in optimizing their WAN connectivity, why I think the Axial Talari partnership is a good way to go. From an Axial perspective, we've been around for 25 years, and we've been in that time specializing in our key core areas, which are visibility, optimization, security, network management, and services. So we're very well experienced, we're very technically driven, and are quite a capable organization in all of those areas. We don't spread ourselves too thinly. We have a lot of expertise in those core areas. And part of our job is very much to look at new technologies and take things that we find are interesting and think our customers will enjoy and be interested in as well, and introduce them to the UK market. That's very much what we've done with Talari. We met up with them a year or so ago and signed up with them at the end of last year. We think they have a very innovative and interesting and unique capability that will help our customers to get the best out of their multiple connectivity and WAN areas. So if I can hand over to Alex, would you be ready to go, Alex?
Yes, I am, Guy. Good morning, everybody, or good afternoon, depending on which part of the world you're in. And thanks, Guy, for the quick introduction there. So we're hearing a lot of discussion and talk around the hybrid WAN these days. And if we think about, why we have a WAN infrastructure, and more importantly, why have we had to, move forward with things like MPLS, is we need very predictable network behavior to deliver very predictable application performance. So everybody's driven towards cost savings, and obviously there is an abundance of reasonably good quality broadband connectivity out there, business grade internet, that kind of stuff. But migrating from one to the other is fraught with risk, right? We're no longer assured through an SLA or predictable behavior. But also, we're looking at this concept of augmenting and aggregating disparate networks together. So adding internet connectivity alongside, maybe a private LAN, or just using, internet from different providers, so we gain resiliency, but we don't necessarily sacrifice the application performance. So obviously, just having dual connections everywhere doesn't actually buy you a whole lot, because most traditional networking technology lacks the ability to see network change, right? And change can be hard in terms of a last mile failure or some kind of circuit issue, but it can also be very soft. Things like jitter, packet loss, the very problems we see with the public cloud and internet become very hard to track in real time, and also very hard to react to. And this is really where Talari kind of sits. We're a technology that overlays on top of the network infrastructure, and it allows us to assess the value, the quality of network paths in pretty much real time, very much so with every single network packet that we send. And then we use that data that we collect to influence how we steer and deliver application traffic to the various network paths that we have. So we actually become somewhat agnostic to the underlying topologies. A WAN path is a WAN path is a WAN path, right? They're all IP-based, and they have network characteristics. And the characteristics are bandwidth, capacity, and then also this measurement of network quality. And that's really, our sweet spot in terms of what we do. We do it, I think, extremely well. And we also now can then take fairly, average reliability network circuits from diverse and disparate WAN providers, but overlay that and provide an extremely high level of resiliency and also application performance resiliency as well. So not only can we now avoid a network outage being an issue, we can seamlessly steer our traffic based on the application type, its priority, and then steer it to the network that makes the most sense. So what we're going to do now is I'm just going to show you a little sort of deeper view of what we do in real time. We have a test bed, and we're going to actually show some application traffic riding that test bed. And then we're going to do some various things to the network infrastructure to demonstrate network change, network failure, and how Talari reacts to that and will preserve the applications across the network. So Donna, if you can go ahead and give David presenter rights, and we'll share the test bed screen. And then David, if you can give me mouse control, that would be great. Okay, great. So what we have, a very simple test bed. We have we're simulating two network sites. On the left-hand side of the diagram, you can see we have a corporate office, and on the right-hand side, we have a branch office. And then at each location, we have various WAN topologies. On the top here, the blue line, we actually have an MPLS network, and that network is very predictable, right? We have a very flat round trip, pretty much no packet loss, and a very minimal amount of packet jitter, in this case 2 milliseconds. And at the corporate center, we have a large pipe. At the MPLS side, we have a small pipe, a T1. And then we also have a Metro Ethernet connection, which is internet-based at the corporate. And down at the branch, we have a couple of different broadband topologies. You know, a cable modem, asymmetric in bandwidth, 8 megs down, 2 megs up, and a DSL modem, again, asymmetric in bandwidth, 3 megs down, 1 meg up. So just having these connections available gives us the ability to do failover, right? In traditional terms, you know, if I lose my MPLS connection, my routing can converge or heal away, and we could fall back to a VPN tunnel, right? Generally speaking, that is a painful experience because things fail, calls get dropped, you know, file transfers fail, applications stop, right? We can recover, but that recovery period is very slow, you know, 30 seconds to 2 minutes perhaps, right? But also, we're not using this capacity that we have in an active passive mode. So the first thing Talari gives us is the ability to take advantage of the connectivity we have, right? But in order for us to do that, we've got to be able to deal with the variability of these networks. And you can see in the internet, in the public cloud here, we've got a lot of variation. We've got differing round trips, we've got bursty packet loss, we've also got jitter, right? Things change, and we have no control over those changes. So if I just steered certain traffic types to these paths, those traffic types would be affected by the change, the delta change in the cloud here. And I'd have no ability to control that. So as you can see, we've deployed Talari boxes in the data path on both sides. We have a single device over here at the corporate office, and at the branch office here, we actually have an HA pair, so an active-passive HA pair here. So if we lost a device, the other one would assume its identity and take over. And then across the network here, we have various applications. We've got a voice over IP call. We've got a video conference going, which is up in the top right-hand corner. And then we've got some data going here. And I'm just going to minimize the diagram. And we'll just start to look at what we're showing on the screen here. So in the top left, we've got a file transfer going. And you'll notice that his throughput is around about 7.5 megs. So we're actually aggregating the bandwidth together to deliver traffic across all the paths for that application. Okay, and you'll actually notice in the bottom of the screen here, we're showing the paths in each direction and how much bandwidth we're putting on each path. And you can see from the NCN site, the corporate site, to the branch, the client site, we have 3 different paths. Now, one unique thing about Talari is we measure network quality unidirectionally. So we don't do round trip calculations. We actually measure from A to B, and we measure from B to A. And that's important because application packets are unidirectional commodities. So as a packet goes from the branch to the client site, the quality of the network that's relevant to that delivery is the quality in that direction. If we used a round trip measurement, half of our measurement data would be irrelevant. And it also would mask the change, the delta change, in the direction we're going. Network quality, network latency is rarely symmetrical, right? Just like bandwidth isn't symmetrical in the public cloud, you know, the round trip isn't symmetrical, and we see that exposed through the Talari technology very, very succinctly. So we're fairly unique in that regard in terms of how we measure the network quality and how we use that to impact the delivery of the application. But right now, we're actually using a high amount of bandwidth in that direction across all 3 of those network paths. But this is a combination of applications. As you can see in the top right-hand corner, we actually have a video conference. And David, if you can just wave your hand in front of the camera there, and you see David is actually a real person, and he's going to perform some very manual tasks for us here. And David, just go ahead and pan that camera around and show where we're at with that. And this actually sits in our engineering office. We have, you see on the far end of the table there, the other voice handset. And that's our lobby and some interop awards that we've won there. So what we're going to do is we're going to do a couple of very simple things here. First of all, we're going to be listening and looking at the video to see how that's affected as the network changes. We're going to also look at the bulk data application on the graph there. And in terms of priority, the things that are important to us are our voice call, our video, and then our bulk data. So as we impair the network, as the network changes, something's got to give, right? And the thing that's going to give the greatest is our bulk file transfer. As we start to contend for network resource, we're going to sacrifice that in some regard. Okay, we don't want it to fail per se, but we don't necessarily care as much about the quality of that application as we do about the interactive applications that we have. So, Donna, go ahead and I'm not sure if David is muted, but if you can unmute yourself, David, and let's just see if we can listen. Just turn the volume down on that a little more. Perfect. So what we're listening to there is the voice call on hold. And David, if you can just turn it down just a hair more, just a little too loud. That's perfect. We just want to be able to hear that in the background. So we actually have a SIP call going. I'm sorry, an RTP call going. And that call is on hold, and we're listening to the hold music. So the first thing we're going to do is a very simple test, which is we're going to fail our MPLS WAN link. All right, so David, if you can go ahead and just pull out the WAN link for the MPLS. So this is basically just like a last mile failure. We've lost the circuit. And what we notice right away is we lose bandwidth on the bulk file transfer because we just lost 1.5 megs of bandwidth in that direction. You can see that he dipped down and he recovered to about 6 megs, but he's doing less. In the Talari view, you can see that the path has gone dead because we no longer have a conduit going across it, and we're not seeing any traffic in either direction on that link. So we're not going to use it, so we instantly move away from trying to use that network path, so we seamlessly fail over. And David, go ahead and wave in front of the camera. You can see that our video is pretty much unaffected, and our voice call didn't get disconnected. So let's go ahead and put that one back in. And as the circuit comes back up again, we're going to notice that we don't initially trust it all the way. We're going to say, he may be good, he may be bad, but after a short period of time, we'll bring him back into service, and then we'll start to use him again. And we'll see the state change back to good, and we'll notice that our file transfer went back up to about 7.5, 8 megs. Now let's go ahead and, David, let's go ahead and fail the red one. This is a larger capacity circuit, but it's a public circuit. So again, our important applications aren't really affected because we still have capacity on different circuits. But right away, we lose 90% of our throughput because there's not enough capacity now for our file transfer and these two other applications. So right away, he's dropped right down to 1.5 megs. Now, he's still going, but at a much reduced rate. And go ahead, David. Let's go ahead and restore that. And again, we'll see him come back into an untrusted state, a bad state. And then once we verify that the circuit is stable, we'll bring him back into service. And then this will again, the file transfer will ramp up here. And there we go. So we're back to good, and our file transfer now will expand to consume the bandwidth as he needs to. Now that's all well and good, and that's all very interesting, but circuit failure is a pretty easy thing to protect against. This demonstrates the ability to augment and aggregate bandwidth together. But more importantly, we want to know what happens when things don't fail, but they change. And you can see in the path stats here that we're showing a latency, jitter, and loss calculation or measurement for each of these paths. You can see what we call best one-way trip time, the latency in that direction. And, they're all performing at a reasonable rate here. Most of our latency in that direction is between 20 and 30 milliseconds. And David, go ahead and mute yourself again for a second. Great, thank you. Sorry, that music can be somewhat annoying after a while. So we have a latency characteristic in each direction here, and we have a little bit of bursty loss on some of these paths and a little bit of jitter. But what I'm going to do now is I'm actually going to use our WAN simulator to influence network change on some of these paths. So they won't actually go dead. We won't have a physical state change, but the quality will degrade, and we want to see how their circuits now get affected. So as you can see here on the console for the WAN simulator, and this is actually a product we build and sell because we needed something that could give us a very high rate of variability. I can now vary the packet loss and delay and jitter on each of these paths independently. So what I'm going to do is I'm going to fail the MPLS path, but I'm only going to make him fail because he's going to have a high level of packet loss. And I'm going to do it in one direction so that we can highlight the fact that we can actually detect not only what the problem is, but in the direction the problem is going. So you see we have a path here, client MPLS to NCN MPLS and NCN MPLS to client MPLS. So what I'm going to do is I'm going to make the packet loss on that circuit really high. And we're going to say about 26% packet loss. And you notice that the circuit, I went too high initially, but the circuit, we're detecting the packet loss. We can see it here, and it's showing up on the graph here. One thing to note here is it's not necessarily a linear loss characteristic here, because we do randomize it to a certain degree in the WAN sim, so it becomes a little more realistic in terms of how the loss gets represented. So we're detecting that the path is there because we're seeing some state, but it's a bad path, right? We're not really going to use that path now because, you know, we have alternative good paths that we can deliver the quality across, right? And David, if you just unmute yourself again, I just want to show that the application call, perfect. You know, we can still hear the voice call going, way in front of the camera, we can still see that our video is good, even though we have a bad path. If I go ahead and I induce a little bit of packet loss on one of these other paths here, raise this up here. Again, now we've got two bad paths in that direction, and the thing we can see that was greatly affected here was the file transfer, right? We no longer have quality bandwidth in that direction. So even though we could put traffic down those bad paths, it's not really buying us anything because we then have to recover the lost packets on the receive side. So again, the thing that gets squeezed first is our bulk file transfer. We're actually squeezing him down to make room for our other application. So I'm going to restore those paths. So take the loss away. And what we'll notice is after a short period of time, we've assessed the quality of those links. We'll bring them back into service. Right? Go ahead and put yourself back on mute there. Actually, no. Yeah, there we go. So right away, again, we see the paths come back into good service, and we allow our applications to consume the bandwidth. So right there, we can see that not only can we deal with outright network failure, we can now deal with relative degradation of network quality, right? And we can also do that with a reference point to the application. So if our application is real-time in nature, like our voice call we're listening to, our video, we can not only prioritize him above the other traffic, but we also put him on the best network path. So our important applications always get put on the quality path. If the quality of the path changes, we can move them seamlessly so that we're always trying to preserve the application performance. Now, in terms of truth and advertising, we're just going to fail all the links so you can actually hear that, yeah, applications do stall out and freeze. So, David, let's go ahead and let's pull the MPLS, the DSL, and then pull the cable modem. So I'm just going to fail the entire network so we can see that, yeah, this isn't a lie. You'll see that right away we lose our paths, and when we lose the last one, we lose the voice call and the video momentarily. David, pull it, count to 5, and put it back in. Yeah.
1, 2, 3, 4, 5.
Great. Now, one thing to note: when we have no paths and we get one come back, we use it immediately because that's better than doing nothing, right? So yeah, we lost the entire network. We didn't do it for long enough that the applications disconnected, but in this case, we were able to come back and start using our path again. Thank you, Dave. You can go put it back on mute now, and go ahead and restore the other two paths. And that, pretty much in a nutshell, is what we do. We're able to detect network change and detect it in such a way that we can influence how we're delivering the applications across the networks, right? And I think we're somewhat unique in our approach to do this, versus other technologies, primarily because we're getting very, very precise granular measurements of network quality in the direction that's relevant to the application packets that we have. And we have a good understanding of application need versus network availability. And with that, I'll pause there, and if we have any questions that have come up, I'll be happy to try to answer them.
Hi, this is Dawn again. So if you have questions, as I said, you can type them in the chat, or you can type them in, I believe you see a question option also, or you can just raise your hand, and we can unmute you. Alex, we have one question on the types of network connections that will work. You demonstrated, I know, DSL and MPLS is, do we have a list of types of links it works with?
Yeah, we're somewhat agnostic to the underlying technology because we're an Ethernet device, and we're typically sitting behind the WAN routers, WAN firewalls. Essentially, any IP WAN topology connectivity we can leverage, right? So it could be DSL cable modem, MPLS, Metro E, 3G, 4G, LTE, whatever, right? If it's IP based and it's a WAN path and it has bandwidth and connectivity, we can take advantage of it. In an all public internet world, we can discover all the possible paths through the network. So if I have 2 different internet providers on one side of the network and 3 different internet providers on the other side of the network, well, I actually have 6 different ways to get from A to B. And that just, we actually can discover all the possible paths, right?
Okay, thank you. And then we have another one that says, is the prioritization of traffic dynamic or static?
So we have a set of application rules that identify traffic types, things like voice over IP, video, Citrix, that kind of stuff. So we categorize those applications to be real-time in nature, interactive in nature, things like Citrix, or bulk. Now, the priority of those applications is driven by 2 things. It's driven by the application demand, i.e. if a voice call is there, we're going to prioritize that over other things. However, in the absence of something more important, we let lower priority applications consume the best resources and the best bandwidth. But as soon as something comes along that's more important, we'll start to move things and rebalance the application flows so that we can deliver the important application and we can deliver it to the best quality network path. So the relationship between the application and the rules is somewhat static in terms of how we identify what it is, but it's very dynamic in how it gets delivered to the network, and that's driven by the application mix at that point in time and also by the quality characteristics of the network at that point in time. So we're very dynamic in the way we prioritize and deliver applications based on what's happening in the cloud.
Okay, thank you. And then we have a question, does this work if I don't have MPLS?
Yeah, absolutely. We don't care what the WAN paths are. So if you don't have a private network today, we're actually a great story for enhancing the reliability and resilience across, just purely, IP, internet-based IP VPNs. That was the original sweet spot of Talari's model, which was, I don't want an MPLS network in terms of the cost, but I do want it in terms of, the predictability. Well, we can add a layer of predictability to unpredictable networks. The caveat being there is network diversity. A single network, a single provider is just that, and it will fail, right? If all of the connections are from the same provider, they're all going to look the same at some point in time. They're going to correlate in terms of their characteristics. So diversity of last mile, diversity of carrier becomes really important to leverage this kind of technology and make a very high reliability statement on top of very unreliable components.
Okay, this is a good question. What happens when all links are poor quality or very high latency?
just to my point of, if everything looks the same, you have nothing to choose from. That's actually basically the same thing. Now, the key there is correlation, right? If all of my links are bad all at the same time, then I have a bad network, no matter what Talari can do. But what we generally can do, because we're seeing this on a per packet basis, and every packet that gets sent is part of the measurement process. As things vary, if they're different providers, they vary at different times. So we can always generally pick our way through the network path despite the high variations, right? The downside there is when they become so bad that even the best path isn't very good. There's not much I can do about that. But I can always pick the not the best path, but maybe the least worst path at any point in time despite that. To give you an example of that, we actually have an office in India, and we have no private line connectivity to that office. In fact, we have 8 different service providers providing 8 different WAN links into that office. And they're all terrible, right? They all vary, and they're all terrible. But they don't all vary, and they're not all terrible all at the same time. So we can still, despite the fact that at any one point in time, at least 3 of those WAN links are completely useless to us, still deliver very high reliability of applications across the network because we have a Talari there. And we our own dog food in that regard, right? So the only way that works is we have a very high level of diversity there, right? There's an old phrase, I think it's a military term, which is 2 is 1, 1 is none, right? So if I have 2 networks, one of them's not going to work for me. And then I have to assess, well, is 1 good enough for me, right? Well, if the answer is no, then I perhaps need 3, right? So 3 is better than 2, right? And 2 is better than 1. Well, 4 is really good, but you know, there's an economy of scale here as well. And generally, what we see is the sweet spot for internet-only connectivity is 2 to 3 with links, depending on the diversity of those links and the quality of those links, right? If they're not really very good, you probably need 3. If they're actually really good, you only need 2, right? But at some point in time, a network is going to fail, and it doesn't matter if it's MPLS or internet or whatever, right? They do fail. That's the characteristics of networks, right? And what Talari enables us to do is make that network failure an unimportant issue to us from an application perspective. Yeah, I know my network failed and I want to fix it, but my technology and my resiliency is such that it didn't affect my day-to-day business, right? And we can work towards fixing that network, you know, at our leisure almost, because it hasn't affected our user base and it hasn't affected our applications.
Okay, what is the management overhead on the network?
So we're encapsulating. So every path becomes a tunnel, so there is some tunnel overhead. I'd say it's about, you know, depending on the packet size, somewhere between 5 and 10%. The management overhead of the Talari is pretty trivial, right? We define the configuration singularly, so we have a centralized management control. And we don't have to go and discretely configure every out there. We build a definition file, define the WAN links, define the sites, and the Talari actually will build the node configs dynamically, work out the bandwidth in each direction, work out the paths in each direction, apply the application rules, et cetera, build the route table. So once we understand what the topology looks like, it's actually a fairly easy process to build a Talari config and a fairly easy process to roll this out. And once it's in, it doesn't really change very much, right? We're dynamic in the way we react to traffic. And the day-to-day business of looking after Talari is pretty trivial, right? Maybe we add a few application rules. If we've added a new site, we're going to build a new site config. So management complexity of this post-install is trivial. You know, it's less complex than you know, defining, you know, firewall rules on a Cisco ASA, for example. It's less complex than having to understand how BGP works and things like that. It's really, what are the subnets, what are the WAN links, what are the applications, done, right?
Okay, and it looks like we have one last question. How does Talari interact with an existing WAN op solution?
Excellent question. I couldn't have asked it better myself. So WAN op generally is already in the install base, right? It's in the infrastructure. It's a commodity technology. It's been around forever. In fact, a lot of people here have worked for WAN op providers, myself included. To us, they look like an application. So they generally sit to the LAN side of us, right? So we go through our WAN op device first, and then we go through the Talari. And to them, we look like a cleaner, flatter, more predictable, bigger network, right? We're zeroing out packet loss, we're aggregating bandwidth together, and we're smoothing out the effects of jitter. So the things they do well is deduplication, compression, and proxying of the application. The things we do well is make the network clean, always pick the best path for non-bulky applications like voice over IP and video, right? And the two actually hang extremely well together, right? They're very complementary technologies. That's also driven by the fact that, the WAN op providers are starting to trying to understand what hybrid WANs mean to them, right? Well, what we do is extremely computationally expensive, right? Which is why we're always going to be the best of breed in terms of hybrid WAN connectivity, right? And I certainly could put WAN optimization in my box, but I'm never going to be best of breed in that market. So, in the real world, we want best of breed in WAN optimization, which generally most enterprises already have. And then we want best of breed in terms of hybrid WAN connectivity, which generally leads you to Talari's door, right? And the two together give us the best of breed in terms of network reliability and network optimization.
Okay. All right. I believe that's all the questions. Guy, would you like to kind of wrap up with us?
Yes, certainly. Thank you very much, Alex. That was very interesting, and hopefully everyone listening found that a good overview and a really good demonstration of the resilient capabilities of Talari and how it can provide massive extra resilience to a WAN. Obviously, there's inherent cost savings as well if you can cut down the number of WAN links you have through utilizing the ones, a fewer number all of the time. There's some pretty significant cost savings you can make, and obviously the performance benefits we saw pretty clearly demonstrated through using Talari. We have a lot of customers, actually, many of them on the webinar now, that have bought WAN optimization products. We sell those. We think that there's a very, very good coexistence with Talari and the WAN optimization products that are out there. If you've got, as Alex said, if you have a clean WAN provided by Talari, then the WAN acceleration products can work much more effectively, and you can get much better returns on your investment with those if you've got a clean bandwidth. So hopefully everyone found that interesting. This is really a sort of hopefully whetting your appetite webinar. We'd very much like to have some more detailed conversations with you. The call to action for our side of things is we're going to be sending out thank you for attending the webinar and some details of the account manager who will be contacting you over the next few days. And we'd love to come and have a further, deeper discussion about what Talari can do in your environment. So if there's no other questions, I'd like to thank you again for taking the time out of your day to join us. Hope you found it interesting, and we look forward to picking up on this with you in a bit more detail over the coming days.
Thank you, Guy. And I do want to let all the attendees know that this was recorded. So if you think it's interesting to someone else in your organization or someone else that you know, the follow-up email will probably include a link to the recording, and you'll be able to share that with other people. So again, I want to thank everyone for attending and all of our participants for participating. And everyone have a great day.